give us some extra work here. Chapter 9, we start getting to talks about different types of transformations. Translations, reflections, dilations, rotations. So in the first section we're going to take a look at, section 9.1, we start to talk about reflections, okay? So a reflection, what is it? Basically you can think of a reflection as a flip of a figure. Alright, so it's like I'm taking one hand, I'm just sitting here and I just go whoop, and there's my reflection. Okay, so a reflection simply, we're going to flip one figure over a line, we can flip it over a point, we can flip it over a plane. For the most part though, our main focus will be on reflecting over a line. So we could be a line like y equals x, which is the plane diagonal line, could be the y-axis of the coordinate plane, could be the x-axis of the coordinate plane. It all depends, but for the most part, we'll flip over a line. A point that we might flip over as well, the origin. Very easy to use, simple, centrally located in the coordinate plane, so we'll probably do that a little bit as well. But anyway, the line that we reflect over, we refer to that as the line of reflection. So you can see down here in the lower left-hand corner of the board, I've got a triangle ABC. The initial figure that we're given in any type of transformation is called the pre-image. Once we perform a transformation, whether it's a reflection, a translation, a rotation, or dilation, the second figure that comes about because of that transformation is known as the image. Now the nice thing with reflections is this. Here we can see I've kind of taken the figure and reflected over the y-axis. When you reflect a figure in a point or in a line, the original figure, that pre-image, and the new figure, the image, will always be congruent. The size doesn't change, the shape doesn't change, it stays the same. So that allows us to say that, hey, these are the exact same thing, I know they're congruent. That's going to come in handy a little bit later when we get into chapter 4. And we start taking a look at congruence of triangles. So, something to keep in mind there. The one thing you may also notice here is right by the C and the B and the A in the upper right hand corner, you see these little almost like apostrophes. Those are little symbols that we call prime. So this is like A prime, B prime, and C prime. You'll hear me say that from time to time in class and again in the notes. So. Like I said, reflection keeps congruence between the figure that you're reflecting and the figure that comes about because of the reflection. So we call that a congruence transformation, all right? Which we can also call an isometry. A little piece of vocabulary there for you. So if you hear me say the word isometry, or if you hear me say the phrase congruence transformation, they're the same thing. Basically means that the transformation that's taken place, whether it's, again, a reflection, a dilation, rotation, or a translation, those will hold congruence. Most of them will. Dilation, we find out, doesn't. Okay? So when it comes to reflecting or reflections, 4 things we're going to take a look at. Reflecting over the x-axis, reflecting over the y-axis, the origin, there's our point, and the line y equals x. So if we reflect something over the x-axis, whether it be a point, a segment, any type of figure, like a triangle, rectangle, pentagon, any type of polygon you have on your coordinate plane. If we reflect over the x-axis, every point pretty much remains the same with one exception. The y-coordinate of every point on that figure, or in that segment, the y value changes sign. So basically, if you take every order pair and you multiply the y-coordinate by -1, you now have all your new order pairs to plot and create your image. And we'll show you how that works here in a minute. The y-axis, very similar to flipping over the x-axis, except now we're flipping left to right, whereas with the x-axis we'll be flipping up and down. So the y-axis, again, every order pair is going to change, but the only thing that's going to change is the x-coordinate. It switches signs. So if it was positive before, now it's negative. If it was negative, it's now positive. If we reflect something over the origin, The ordered pairs stay the same except both the x and the y now switch signs. Okay, so we can do that, we can achieve that by multiplying the x and y by -1. Or if you just remember, hey, flipping over the origin, I gotta switch the signs on both the x and y coordinate, I'm good. And then finally, if we reflect something over the line y equals x, so basically here we're saying, hey, here's my coordinate plane, here's the line y equals x. If we reflect over this diagonal line, then what happens is the x coordinate and the y coordinate just switch positions. So y becomes x and x becomes y. So now I'll give you a second here. We'll take a look at two quick examples of reflections. The first one, I think we reflect over one of the axes, and the second one we flip the figure over the origin. All right. So here, if you want to pause so that you get a chance to write all the information down, now would be a really good time to do that. There's a lot of points here, a lot of things going on with the pictures, so pause now if you feel like it. Okay. We want to reflect the triangle ABC, where we've got 3 points at 1, 2, -1, -1, and at 3, 1. We're going to reflect that over the y-axis. All right, so you see I've developed a coordinate plane. I've plotted all 3 of my points. And what I've done here to the side is written down all 3 points with their ordered pairs. So what I'm going to do is I'm going to apply the transformation, which, again, reflection over the y-axis. So that means that the x-coordinate is going to change sign. Okay, so if it's a positive, I'm going to make it a negative. If it's a negative, I'm going to make it a positive. In point A, you've got the point 1, 2. The only thing changing sign is the x-coordinate. That's why I have a nice underline here. So my x-coordinate's a positive. I'm going to make it -1, 2. Here I've got a -1. It's now positive. Notice the y value's not changing. Positive 3, now -3. All right. So now these 3 points here, these 3 ordered pairs in blue, those are my new ordered pairs for my reflected figure. Okay, my image, if you will. Here's my pre-image in red. My new image, -1, +2, 1, -1, and -3, 1. All right. So there's my new triangle. Here's B prime. Here is C prime. And there's A prime. And we put the primes here to distinguish between the original ordered pairs and the brand new ordered pairs. So that's how you reflect something over the y-axis. Notice shape, pretty much the exact same thing. I know that triangle ABC is congruent to triangle A prime, B prime, C prime. Same size, same shape. Angles haven't changed, sides haven't changed. We've just kind of moved where the points are located. All right. So then down here, the last one. We've got a quadrilateral, ABCD. We've got all 4 of our points. Again, you see I've graphed the quadrilateral on the coordinate plane. I've listed my points with their ordered pairs here so that we can easily see how each ordered pair is going to transform into its brand new ordered pair. We're reflecting over the origin. So if I'm reflecting over the origin, that means that the x and y coordinates will both switch signs. So here I've got point A. My x coordinate was negative, now it's a positive. Y coordinate was positive, now it's a negative. 0. If you have 0, you can't really change the sign on 0, it stays the same. 3 becomes a -3. We got -2 and +1. Again, 0 stays the same. -2 here becomes +2. So I've got my brand new ordered pairs. A prime through D prime. I can plot those on the coordinate plane. There's A prime. D prime is at 0, -3. C prime at -2 and 1. And D prime at 0, 2. Alright, let's see if I can. Alright. There we go. Hopefully that shows a little bit better for you. Again, when you've got these figures and they're not in a specific quadrant and they're kind of all over the whole coordinate plane, when you go to reflect it, they're going to overlap each other. Okay? Key things to remember: 1, just stick with the information I gave you on the last board. Okay? How you need to change things to reflect over the x-axis, the y-axis, the origin, the line y equals x. The pictures will come out fine. Don't get freaked out by it. But that's it. That's how you do reflections. We'll work on more of these in class tomorrow. And hope you have a great day. See you.